One orca is gripping a dead sunfish. A second rolls belly up, accelerates, and strikes it with a thud. The impact scatters tissue. A juvenile swims into the cloud of fragments and begins eating. Researchers call the sequence ram to fragment. It looks deliberate. One adult stabilizes the carcass, another delivers the impact, and a younger animal takes the smaller pieces. But this is not evidence of a new hunting culture, not yet. Scientists have documented this ram to fragment behavior only twice, and because both sunfish were already dead, the strike was not the killing blow. So what are these orcas doing? Processing food, helping young animals, practicing a skill, or combining all three? The first event happened on July 29, 2024, off San Jose del Cabo at the southern end of Baja California. The group included 3 adult females, 1 adult male, and a juvenile. An adult female carried a sharp-tailed sunfish by its clavis, the rudder-like structure at the rear of its body. The fish was already dead and its viscera had been removed before recording began. Then the adult male approached at speed, turned his pale underside toward the surface, and lined up with the carcass. The female released it just before impact. The collision was loud enough to be heard on the recording. Tissue scattered through the water. The juvenile entered the fragments and ate smaller pieces, while adults consumed the larger remains. Because recording began only after this predation, the study cannot tell us how the sunfish was killed or how its viscera were removed. It captures the processing stage, not the full hunt. On September 7, 2025, observers recorded a second event in the same region. This group consisted of 3 adult females and a calf. Earlier, the orcas had hunted a mako shark. Later, they encountered another sharp-tailed sunfish. Again, one adult held the fish while another struck it. Again, the impact fragmented tissue, and again, a young animal fed after the impact. That repetition matters. The same coordinated sequence appeared in 2 different years, with a juvenile present in one event and a calf in the other. But there is a crucial limit. Researchers could not confirm whether the same individual orcas participated both times. These may have been repeat performances by experienced animals, or separate groups arriving at a similar solution. 2 sightings cannot distinguish those possibilities. A sharp-tailed sunfish is a molid, a member of the unusual family that includes the world's largest bony fishes. Its body presents a peculiar engineering problem, a thick, gelatinous collagen layer called the capsule. That capsule is nearly 90% water. That anatomy may help explain the sequence. The prominent clavis may offer one orca a place to grip and stabilize the carcass. A concentrated impact from another animal could then disrupt tissue, creating smaller portions. It is a compelling mechanical explanation, but it remains a hypothesis. The researchers did not measure the orca's speed, collision force, or the physical strength of these particular fish. The videos show that fragmentation occurred. They do not provide a laboratory test of precisely why. The clearest possibility is food processing. Instead of every animal struggling with one large, slippery carcass, 2 adults convert it into accessible portions. In both observations, a young orca fed after the impact. That pattern could represent parental investment, adults spending energy to make food easier for a juvenile or calf to obtain. It might also create an opportunity for social learning. The young animal close to the action can watch where to grip, when to release, and how another orca approaches. Yet feeding a youngster does not prove that the adults were teaching. Teaching requires stronger evidence that an experienced animal changes its behavior in a way that helps the learner. The authors also leave room for play or social interaction. Orca play can involve forceful manipulation of objects, and play may overlap with practicing useful movements. Because the fish was eaten, foraging clearly mattered, but the same event could still serve more than one function. Orcas are famous for locally specialized ways of finding and handling prey. Different populations cooperate to create waves, herd fish or raise, and manipulate animals much larger than themselves. The new observations fit that broader pattern of flexible, coordinated behavior, and sunfish are not unknown prey in this region. The paper points to 21 documented orca-molid events involving 17 identified orcas from at least 4 groups. What appears rare is the complete stabilize, ram, and fragment pattern, which was recorded in only 2 events. That distinction matters. 21 interactions show that sunfish are part of the regional prey picture. They do not show that ram to fragment is widespread, traditional, or newly invented. There is also a camera problem. More tour boats, observers, and high-quality recordings can make a rare behavior suddenly appear new. The footage may reveal an emerging technique, or simply expose one that people previously missed. To learn which explanation is right, researchers need repetition, clear identification of every participant, the condition of the prey before the strike, consistent roles among adults, and evidence that young animals later perform the sequence themselves. Until then, Orcas invented a food processor is a brilliant headline, not a scientific conclusion. What these videos establish is narrower and more remarkable. At least twice, adult orcas coordinated a precise sequence that fragmented prey tissue while a juvenile or calf fed afterward. The behavior joins anatomy, timing, force, and cooperation in a way that looks anything but random. Whether it is learned, shared, playful, or independently rediscovered remains open. The next time one orca grips a sunfish and another rolls upside down, every frame will matter, because tradition requires evidence that a behavior is repeated, socially learned, and shared.